was nice. Thank you, Katie and Ann. Katie and Ann. Some really terrific presentations. Some context to some of the things that you spoke to in my presentation, and really like the work that you did for VDOT with taking a look at NPMRDS. So much like what many of the other presenters prior to me were sharing with you this morning, what I want to impart is how, much like what Eddie did and shared with us with the work that he does with Disney, a lot of what the CATT Lab does is they build tools and technology so that our users, our community of users like VDOT, MDOT, all the other state DOTs that use our technology across the country can tell stories with their data, the stories with data visualizations. The National Performance Measure research data set is largely what I'm going to focus on, and some of the analytics and output information products that are derived from that set of tools, if you will, that we develop at the CATT Lab. Those tools, as Michael had mentioned earlier, are leveraging probe data. Probe data, example of that here, versus some of the traditional sort of road sensor-based technologies that, unlike deployed, embedded, like detector loop sensors or hard-fixed camera systems that give us some insight as to the movement, flow, and condition of the roadway. These new probe data sources are giving us real-time data and an understanding of flow, in some cases volume, from some of our third-party probe data providers at tremendous rates with some fantastic coverage on our network. So Justin asked, well, are you getting coverage from this probe data on arterials? This is a snapshot of DC, or this is an inset map of DC probe data. This happens to be INRIX data. Here could probably deliver the same, but this is speed data on nearly every single segment of road data that's within the city. So tremendous amount of data flowing to state DOTs every minute. That's the cadence, every single minute. And just to give you a sense of how big this big data set is, just in Nevada alone, for NPMRDS, we're processing 276 million records every year. In Florida, it's over 1.5 billion records every year just for NPMRDS. And again, NPMRDS is largely just the NHS system. We have an expanded data set that we provide through that program that's just beyond the National Highway System and covers some additional arterials. But this is big data, right? Tremendous data. And it's kind of, again, what we do at the CATT Lab is we kind of take all of that in. We've got practitioners that are data visualization experts and data scientists and software solution engineers and dozens of these folks that take their expertise and their knowledge, and we help build really meaningful technologies and tools so that you could tell a story as a state DOT. From an NPMRDS perspective, a lot of the reporting examples or reporting tools that we develop and make available to the users across the country are to support things like project prioritization, after action assessments. Saw a really interesting presentation from a colleague of yours from Washington, D.C. last week that focused on sort of the safety assessment. Like they deployed some safety measures across the city, and they used CATT Lab tools, probe data analytics, which is NPMRDS, to support a safety assessment of their deployment of these technologies. So all of this great technology, all these great tools, all these smart people at the CATT Lab and folks like Amy, Katie, building these great visualization tools, they help tell a story. So I'm going to share with you some stories, user stories, that some of our customers or users across the country have leveraged to support some of their own interests within their own jurisdictions. This is a great example of some work within PennDOT that was done. They had a major work zone that was set up off of I-95 to do some lane widening in a particular area of, I think it was around Philadelphia. This box and whisker performance chart shows some natural trends of AM and PM peak traffic, both in the southbound direction and the northbound direction. The green box and whisker charts indicate traffic or congestion prior to construction, but then the orange and red box whisker representations here illustrate the congestion during construction in orange and in red. So construction periods were 2013 and 2014. If any of you are familiar with the nature of a box and whisker chart, within the box you've got the 25th and 75th percentiles, and those whiskers are the 5th and 95th percentiles. So you got these crazy, wild variations of congestion. What was interesting about this work that they did in developing these performance charts for I-95, where they were doing the work zone, is they leveraged them to justify some additional spending for transit. So hey, we've got some crazy conditions here that they were able to quantify in terms of congestion. You know, all of this performance assessment has an impact on user delay. That quantified measure, these charts help illustrate to legislators and executives that, hey, maybe if we apply some transit dollars, we can help reduce some of this congestion. Another interesting case study down in Georgia. I think most of us remember just through media that there's a bridge collapse in the Atlanta region. Horrific impact on congestion. This is a user delay cost chart. Michael had mentioned this. It sounds like most of you are familiar with this. This user delay cost chart has time in the X for a single day, 12 a.m. to 11 p.m. or full day. And this is in the Y is every day in the month of August or whatever it was during the year that the bridge actually collapsed. So in the Thursday and Friday, the day of the collapse and the delay and the day after the collapse, we saw some running these user delay costs. Georgia DOT was able to quantify the congestion at $7.2 and $7.8 million, roughly an increase of 20% just for that bridge collapse. Other terrific case study, user story, if you will, that was told using NPMRDS, some of CATT Lab's tools, was this another construction project in New Jersey on the Garden State Parkway. A lot of folks during the summertime head down New Jersey Garden State Parkway in New Jersey to Cape May. Lots of congestion heading down that way towards Cape May throughout the summer. They wanted to spend a couple $100 million. There's lots of resistance. The media gets a hold of it. You know, why are we spending $200 million? People get to Cape May eventually. What's the problem? Well, here, another opportunity to take data visualizations, take technology, tell a story. What they did with this $200 million is try to, along this corridor, here's Cape May in New Jersey, along this corridor there are several signal lights. These signal lights created backup and congestion, as I'll illustrate later. They wanted to do is, I thought there was going to be, I'll show you a diagram of the results. These signal lights create significant delays and congestions and backup throughout the summer months. This is a This is a congestion scan for that corridor. Imagine, you look back at this corridor here. That geography is represented by this kind of illustration of that same corridor. Each one of these elements and graphics represents a junction or an intersection along that corridor. And if you know anything about congestion scans, you can see that there's some clear congestion or backup at several different intersections at different Saturdays prior to the work that was actually done on that corridor. This is a congestion scan of those same that same corridor, same intersections for the 7 Saturdays during the time that construction of the work zone was active. Again, really interesting telltale signs that, hey, we've got backups throughout the day from 8:45 to 6 p.m. on average throughout this intersection. Let's get rid of these signals. So what they did is they took these signalized intersections, they created these overpasses at these intersections, and so now there's an opportunity using these tools to tell a story that says, hey, how do things look afterwards? Dramatic difference, right? So here's the same corridor, the same intersections. This is an illustration, same time period for the 7 Saturdays after they removed the work zone signs. You notice that, one of these intersections, you get a little backup here and here, maybe an accident or so, but for the most part, even after just the removal of the work zone signage, we saw some clearing of traffic and congestion nearly removed after the signals were removed. So wonderful illustration. There's also some terrific tools to kind of illustrate that same story using trend maps. This is before and after, before and after congestion. Also lots of terrific tools to help tell a story about before and after action studies. Major events on the roadways. Here in the DC region, we've got lots of bridges. We get a wreck or an incident on our bridges, and it's going to jack everything up for hours. We can see that again in congestion scans, a great way to illustrate the congestion, the extent of congestion in terms of miles, the impact that it has on creating secondary collisions and incidents. These trend maps that are animated, they're not animated here in this overhead, but you can animate over a period of time the impact that incident had on not only the bridge and 495, but also some of the arterials, how it impacted them. And then user delay costs. Thank you, Barbara. Also, wonderful way to communicate, tell a story with the general public, with others within a broader community outside of your state agency, might be with some of these tools. So these trend maps, they can actually be embedded. You can actually take code and embed these trend maps to tell a story on your website. You can also take screen grabs of these congestion scans. That helps tell a story. You're doing the same thing that I was doing, Barbara. And then sharing this openly with the public, saying, hey, if you travel on the Tuesday before Thanksgiving, this is what it's going to look like as compared to a normal Tuesday. So maybe consider taking traveling at other days of the week, other times of the day. Our friends at GDOT put together this really nice illustration or information graphic, and they populated this, developed this chart, this info product, this infographic to share with the public based on NPMRDS analytics and Pro Data Analytics. I'm out of time, but this is a really cool animation showing nationwide impact that the eclipse had on traffic flow. And in closure, we'll see that as the eclipse comes through, you'll see some major, it's it's better to look at these side monitors. You can really see the congestion show up as the eclipse is kind of wrapping up. There's major backup in parts of South Carolina in particular. I think 60 miles in some cases. So here again, a trend map at a national level told a really cool story about the impacts of congestion. So get out there, not only use these tools to help answer performance measures related questions within your agency, but use them to tell stories as well. I think it shows an impact with the public. Thank you. I don't, but we can put you in touch with folks at PennDOT that can give you some more specific feedback. So hit me up afterwards. I'll take your card and put you in touch with the right person.
In your presentation and in all the presentations, they talk about segments. From your experience, what's the subjectivity or concern about segmentation and having the, some sensitivity or analysis do you do to see if segmentation affects your output?
Yeah, so it's a good question, and correct me if I'm wrong. The question about segmentation is about the length of segments or the analysis?
Having the right ones, like, is your output dependent because you were looking at this segment versus a different segmentation?
Naturally, any analysis that you do with any of these sorts of tools is relative to the question that you ask. The question that you ask has two main sets of criteria, both a spatial context or spatial criteria and temporal criteria. That spatial question you define as the user. This is where I want to start my spatial analysis, and this is where I want to end my spatial analysis. And that temporal is what are the time periods, day of the week, time of day, so on and so forth. So you have full control over that before you run the analysis.
Right, but so do you try different segments to see if you are looking at something that's skewed, or?
Certainly you could. Michael, you have some input?
Well, I was just going to say, we've got some clients that use these tools that just go in and kind of select everything, and they run a query. And what happens is they've chosen too many segments, and the good performing roads cancel out the poor performing roads, and they get back a number that doesn't make any sense. And they're like, well, the tools don't work. It's like, well, no, you selected too many roads. You're not analyzing the right area. So you kind of have to go in and run the queries multiple times. The first one is just to find the problems. The second query is then to narrow it down and figure out, okay, what's going on at this location versus this other location. And you're ultimately trying to solve a problem. You don't want to fake a problem by choosing the wrong segments, but you don't want to underestimate a problem by choosing the wrong segments as well. So there's a fine engineering line that has to be worked there.
Thank you, Michael. Other questions?
On that point, we will open the floor to questions for any of our speakers. I know we had to cut a couple of our questioners off before they had a chance, so if you would like to address any of our speakers, please. Michael?
I was just going to ask what software did you use for your visualization and the dashboard?
So I know for the visualizations, some of those things are done in-house, but we're using the React framework that has some Java and D3 stuff in it, like we heard from Anne earlier. But some of those things were created in-house.
Yes, please.
Also for Michael, I thought the time spiral chart was pretty interesting. I was curious, did you guys create that, or was that something you had seen before? And then have you noticed, is it better suited to the timeline for any particular types of questions?
So we did create that ourselves. We did not come up with the idea of a time spiral though, like that's been done many times before. But to your question of the time spiral versus the timeline, I personally like the time spiral because it's easier for me to see patterns and outliers because it's kind of in a smaller space, especially cyclical patterns. That said, because it's a spiral, the outer rings get more pixels than the inner rings do. So you're giving more weight visually to the more recent date ranges, and there's pros and cons to doing that. So some people prefer the timeline view to give equal weight to every single congestion event.
Other questions? Please.
Katie, I noticed that you were doing your dashboards in Tableau. Is that a standard tool in your group, and how does that work for you?
Yeah, VDOT has used Tableau for a while. There is also interest moving towards using a lot more Power BI though, so I think the two are supported by VDOT right now. We have a Tableau server, so you can publish the tools to everyone.